Hello, my lovelies, and welcome to your video on molecular shapes, or sometimes called molecular geometry, or sometimes called VSEPR. VSEPR is just an acronym for valence shell electron pair repulsion theory. And so if you start with, when you open this VET, which there is a link in today's agenda, and you move these two atoms around, you will notice that you can never get these two bonded pairs to be near each other. That's that repulsion that is going on. So if I add a third bonded pair, you'll notice that third bonded pair pushed those two bonded away. Okay, so that is that repulsion. Now it doesn't matter if it's bonded or if it's lone. You will notice the same thing happen when I add that lone pair on. When I add that lone pair on, there is a repulsion. No matter how much I want to put them near each other, I cannot. So the repulsion goes on with bonded and with lone pairs. When it comes towards names of these molecules, there are 5 main shapes that you are responsible for. This first one, you notice the atoms are in a line. They're at 180 degrees apart. You are not responsible for bond angles. You do have to be aware that the angle is the same as top as it is on bottom. So if you wanted to, as you're exploring, click on the molecular geometry piece, it'll tell you the name. But I think because you can see it, and I want to kind of show you without clicking on that, the names of these and how they make sense. So these atoms are in a line. This is linear. I add these lone pairs to it. And what do these lone pairs cause my line to do? Okay, I add a line, add lone pairs, and I no longer have a line. They caused that line to bend. So the name of this shape is bent. I remove my shade away, and I add a bonded pair onto it. I want you to notice that there are 3 atoms, 3 giving us the first part of its name, trigonal. And I want you to notice that another geometry term, plane, this is all in the same plane. So the name of the shape is trigonal planar. Once a lone pair comes into the mix, though, you will notice that lone pair again causes repulsion. It causes it to be forced down. I'm hopeful that if I move this just the right way, you can see the pyramid that is formed with the 3 bonded atoms at the bottom. Okay, so this is called trigonal pyramidal or pyramidal. And the last shape is what if you have 4. So notice I made trigonal planar on one plane, and then I add a 4th bonded pair, and now I'm in a 3-dimensional situation. So this is 4 bonded atoms around the center for a name of tetrahedral. So if we go to our OneNote, which you do have access to this, don't forget. So I kind of already started this so that this video wouldn't be so long. I have these Lewis structures over here already put together. We're going to go through these Lewis structures and figure out the name and how to draw them in its correct molecular shape. So you'll notice on this first one, we have boron and 3 chlorines. Remember, boron is an exception. It only needs 6. You'll notice that this top is empty, okay? There is no lone pairs up here. That is going to be important. So if we're talking about shared bonded regions, it's the bond between boron and chlorine, and boron and chlorine. So there's 1, 2, 3. So there's 3 bonded regions, and there are 0 lone pairs. So because this is empty and because electrons don't like each other, what actually happens in this shape is that they space out. So instead of making a T, it actually makes something that looks like a Y. It does not matter if you have a Y or if you have a weird looking H, but they do need to be evenly spaced out. And in geometry, you learned, hopefully, how to show the bond angles are the same. And that is to draw a little whatever that is. So the bond angles in between all of these are the same. So these are 180 degrees. Nope, I lied, 120 degrees apart. Again, you're not responsible for knowing bond angles, but you are responsible for knowing that it's evenly spaced out. So the name of this one, because it's 3, okay, it's all about the center atom. Okay, on the center atom, how many are there around there? There are 3. So this is going to be trigonal planar. Now, if you look at the one right underneath it, though, let's compare it to what's going on with nitrogen and 3 chlorines. This is boron and 3 chlorines. This is nitrogen and 3 chlorines. And we'll see right off the bat that we have a lone pair. Okay, what does that lone pair do? That lone pair causes repulsion. That's going to affect the shape. So I still have 3 bonded regions, but I have 1 lone pair. I have 1 lone pair up here. So what is that going to do? That's going to cause repulsion. Like I said, it's going to force, or it's going to push the chlorine down. It's going to push the chlorine down into a pyramid. So this shape is going to be pyramidal. Now in chemistry, we kind of signify 3 dimensions by using dashes and triangles. So we dash going backwards, a triangle coming forward. So if you see a triangle coming forward, it's just telling you it's coming near you. It did not look like 2 dots. And then just a line just means it's there, off to the side. And then we got our good old lone pair up there. So the name of this is, and again, you can name it trigonal pyramidal. But pyramidal being the main part of that name. So sometimes you'll see a trigonal pyramidal, or sometimes you will just see pyramidal. So again, I want to re-emphasize the difference here is we have a lone pair on nitrogen, where on boron, it was just empty. It was empty on top of boron, but on top of nitrogen, we had a lone pair. That lone pair caused repulsion, which is why the shape looks different. So moving down to sulfur here, you'll notice we have 2 lone pairs. So we have 2 bonded pairs, and we have 2 lone pairs. So here's our lone pairs again. What do lone pairs do? Lone pairs cause repulsion. Okay, so not that the bonded pairs aren't, but those lone pairs are going to make your shape. Now, some of us draw this where the lone pairs are 1 on top and 1 on bottom. With this, and I hope you saw this in PhET here, and I don't think I emphasized this, with my lone pairs, they put themselves on one side. No matter what I do, I cannot get my bonded to be on one side and my lone to be on the other. No matter what I do, these lone pairs are on one side and these bonded pairs are on another. So keep that in mind when you're drawing, no matter what your Lewis structure looks like. That's why we're writing this 2 and 2 down, so you can see it, so you have something to go back on when in doubt. So this is sulfur with 2 chlorines. Constantly make something look like a line there. There we go. And sulfur has 2 lone pairs. Now, if you want to, and I like to do, is, you know how in that PhET it kind of looked like an alien? That kind of helps me remind myself that there's a repulsion going on. It's up to you, but it is there is that repulsion there that is on that shape. Sometimes you'll see the shape without the lone pairs on top. That's also fine. But when we draw it, we're going to include it. So this is a bent, okay? Because the opposite of that is, and we can see that right off the bat with these 2, is how many regions here? Well, we got 2 regions. Okay, so this is region 1 and region 2. And I tried to emphasize this in class. Okay, so we have 2 bonded regions, 0 lone pairs. So it's already in its shape. This is a linear shape here. We can see that it's in a line. So sometimes in a linear, you will have 2 bonded atoms, But you'll notice right here at chlorine, there is only one bonded, still no lone pairs. And this is also linear. So linear, again, can be written or be 3 atoms total, or it can be 2 atoms. This is also linear. You can see that it's in a line. And our last shape is when we have 4 bonded regions, and we can see those 4 bonded. There's no lone pairs on here. So this is going to go and we're going to go backwards. We're going to come forwards. And we got off to the side. Remember, everyone gets 8 total electrons, correct? So chlorine starts with 7. So we're going to make sure that we have all its electrons there. And this, again, is tetrahedral. So this is a video on our 5 types of shapes, or 5 shapes. We have trigonal planar. We have trigonal pyramidal, or sometimes just called pyramidal. We have bent. There is linear. And there is tetrahedral. Tomorrow, if you have any questions or if you have any concerns with this, put a star by it, jot it down, and ask me later.